This is a new chapter, chapter number 4. Chapter number 4, linear equations in two variables. Okay. So again, this is an introductory video to this chapter. We'll try to uh, understand that why we need linear equations in two variables and what are their applications in certain problem solving in mathematics. So first, let's quickly see linear equations in one variable. We have seen linear equations in one variable in previous standard and how they are also useful in solving certain mathematical problems. So let's take a random example. Linear equations in one variable. Let's say x plus 2 is equal to 3. Is this a linear equation in one variable? Yes, it is a linear equation in one variable. The one variable uh, which is x is the one variable which is unknown in this equation. Is this an equation? Is this mathematical expression an equation? Yes. Why? Because it has this equal to sign. Equal to sign means equation. The word equation is correlated with the equal to sign. So, we are convinced that this is a linear equation in one variable. Now, let's try to solve it. So, I'll just write it once again. This is x plus 2 equal to 3. So, what we do is we subtract 2 from both the sides of equation. So, x plus 2 minus 2 is equal to 3 minus 2. Okay, once again, let me use a highlighter. So, minus 2 and minus 2. We do same operations on both the sides of this equation, which is allowed. If you subtract the same number from both the sides of equation, the equation remains equal or it remains stable. So we have done this minus 2 minus 2. Now, yes, so 2 minus 2 is 0. So x plus 0 will be x. So this will be x, that is equal to. And on the right hand side, we have 3 minus 2. 3 minus 2 is equal to 1. So x equal to 1 becomes a solution to this problem, to this equation x plus 2 equal to 3. Now, we can represent the solution of a linear equation on a number line. So let me try to draw a number line. So let's say this is our number line. Okay, we are going to note all the integers on the number line. So this is the 0 at the center. Then we have 1 here, we have 2 here, and we have minus 1 here, we have minus 2 here, and dot 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 dot. Okay, so this solution of the equation x equal to 1 can be easily represented on the number line, which is here. So x equal to 1 will come on this point. Now let us consider one more equation. Okay, yeah, let me draw a line here. Let us consider one more equation. I am going to say x, let's say I'm going to say 2x is equal to 3. Okay, so x, so again I'm going to divide both the sides of the equation by 2. Okay, we can do division on both the sides of the equation and the equality of the equation is still maintained. Now, as we all know that this 2 and this 2, they'll cancel each other out. So what remains is just x. X is equal to 3 by 2 and that is equal to 1.5. So this is the solution of this equation. X is equal to 1.5. Okay. Once again, this solution of the equation can be easily represented on the number line. Okay. So let's see how to do that. Okay. So if we zoom in a bit, so we want x is equal to 1.5. So 1.5 will be here exactly in the middle. So it will coincide with that green mark that I've done. So this part is our x equal to 1.5. Okay. So the conclusion here is that linear equations in one variable, the solutions to linear equations in one variable can be represented on a number line. That is an important point. So let's go down, and I think that's the point I've mentioned here. Okay, let's try to get rid of this. Yes. Okay, so solutions, let's read it out. Solutions of linear equation in one variable can be represented on the number line. Okay, that is an important note from this discussion. So this was linear equation in one variable, a quick revision which we have seen in our previous standards. Now the main topic of this video is linear equation in two variables. So in order to get into that, let's come to this point. Now we are given one task to form an equation from this information. So let's see what is the information. Yeah. Now Sum of ages, let's read it. Sum of ages of Peter and Julia is 72. So Peter and Julia are two people and their sum of ages is 72. How are we going to represent this? So I'm going to say let age of Peter be equal to x. Then I'm going to say let age of Julia be equal to y. And sum of their ages, sum means addition, sum of their ages is equal to 72. This is how you're going to represent this information, okay, this information in form of this equation, okay. Sum of ages plus of Peter and Julia, x and y, is, so in English the word is always translates to equal to in mathematics, okay. So the sum of ages is, that is equal to 72. So thus here you can see that for this problem, okay, in order to express this problem, we cannot use linear equation in one variable. Linear equation in one variable cannot express this information in mathematical equation. We need to take help of linear equation in two variables. So thus we have used two variables x and y in order to represent this information. That's it, as simple as that. This is the concept of linear equation in two variables. Now, let's see some more examples of linear equation in two variables. This is the short form that I have used, LETV, linear equation in two variables. So we'll see this linear equation in two variables one by one. This is the first example. Okay, here the representation or the arrangement of the variables and the constant is very much similar. We have 2x plus 3y is equal to 4.37. Okay, and x and y are our two variables or two unknowns. Now let's continue further. Yes, now here you can see that x is on right hand side, sorry, left hand side of the equation and y is on the right hand side of the equation, and this is our constant 4. So again, this is also a valid linear equation in two variables, just that the two variables are on other sides of the equation. You can anytime rearrange this into something like this. So I'm going to do that. You can say x minus root 3y is equal to 4. Okay, now this arrangement is similar to the one which we had before, all the variables on the left hand side and the constant on the right hand side. Okay, so in this way we have different forms of linear equation in two variables. Have a look at this. Here both the variables x and y are on the right hand side of the equation on this equal sign, and the constant 4 is on the left hand side. Once again this can be rearranged. Let me do that quickly. So we can say minus 5x plus 3y is equal to minus 4. This is how you can rearrange it. And finally, last but not the least, is 2x equal to y. So here you can see in 2x equal to y, in fact there is no constant. But still, this is also a valid linear equation in two variables, x and y. Let's quickly rearrange. So this can be 2x minus y is equal to 0. So thus, we have seen why there is a need for linear equation in two variables, okay, because certain pieces of information cannot be expressed by using linear equation in one variable. We need to use two different variables to express a information or to express an equation in mathematics. So that's all about this video.